solving quadratic equations using the quadratic formula. And what is the discriminant? The quadratic formula is a very nice formula that we can use to quickly solve a quadratic equation. What we need to do is we need to make sure that the quadratic equation is written in standard form, which means that it equals to 0. And then you can identify your A, B, and C values. A value is always the coefficient in front of the x squared term. The B value is the coefficient in front of the x term. The C is that constant coefficient. Once you have identified those values, plug it in here and you're done. So let's take a look at a few examples. The equation is now written in standard form, so I'm going to identify A. A is the number in front of the x squared, so it's 1. B is the number in front of the letter x, so it is 3. And C is the constant term, which is 5. Once I have identified those values, then I plug it into the quadratic formula, and that's how I find the answer. So the answer is negative b. So what I do is I create parentheses to represent the letter b, make a parentheses to represent the letter b again, a parentheses for the letter a, and a parentheses for the letter c, all over 2a. So then what I do is then I plug these numbers into the appropriate letters. I begin by plugging all the b's, okay? So these are the b's. So the b goes in here, and it goes in here. And then followed by the a's. A is 1, 1, 1, okay? So 1 and 1. And then finally the letter c, which is negative 5. So that goes in there. Once I have done that, I'm going to simplify this statement so that it looks like negative 3 plus minus the square root of 9. This becomes plus 20 over 2. Okay? So therefore, what do we have? We have negative 3 plus minus square root of 29 all over 2. And we're done because that's the best we can do. Number 2. Before we can apply the quadratic formula, we need to subtract 3 to both sides. Identify the a value, the b value, and the c value. Okay. Plug it into the quadratic formula. Negative b plus minus the square root of b squared minus 4ac all over 2a. B goes in here. Okay. A goes in here. C goes in there. And all we have to do now is simplify. So this becomes 2 plus minus the square root of 4 plus 12 times 3, that's 36 over 6. So that becomes 2 plus minus the square root of 40 over 6. 40 is 4 times 10. 4 is a perfect square, so that means you can take out a 2 all over 6. Now they do have something in common, so that you divide them all by 2. So therefore you have 3, and you 1 plus or minus rad 10. And that's the best you can do. The quadratic formula. Okay? Awesome. So what's the discriminant? Well, the discriminant is the value inside the quadratic formula. So if you look under the radical, this is what we call the discriminant. And the discriminant is really special because the discriminant tells us whether or not our problem has one solution, two solutions, or no solutions. So the value that's under the radical is the discriminant. By knowing the value of the discriminant, then we know whether or not there's one solution, zero solution, or two solutions. So here are the scenarios. If the value of the discriminant is a positive number, then the graph will look something like this. The graph will cross the x-axis at 2 different points. Therefore, it will have 2 solutions. If the value of the discriminant equals to 0, then the graph will just barely touch the x-axis, which means that it crosses the x-axis at 1 point. Therefore, it's going to have 1 solution. And last but not least, when the value of the discriminant is a negative number, then the graph will not touch the x-axis, and therefore it will not have any solution. So without even solving the problem, we can analyze the discriminant, and we can tell whether or not it has one solution, two solution, or zero solution. So solve so that you are in standard form first. Now what that means is that before you even apply the discriminant test, you must rewrite the equation in standard form. So over here, we're going to go ahead and add 7. So A equals to 1, B equals to -6, and C equals to 7. Once we have those information, then we can test those solutions by plugging it into the discriminant, b squared minus 4ac. So b squared minus 4ac, b is -6, a is 1, and c is 7. So you have 36 minus 28. 36 minus 28 is a positive number. So this is 8, and 8 is a positive number. If your discriminant is a positive number, then you say 2 solutions. And that's the best you can do. You don't know what they are. You just know whether or not there's one solution, 2 solutions, or no solutions. How many solutions does this problem have? Well, A equals 1, B equals to -6, and C equals to 9. B squared minus 4ac is the discriminant. So B squared minus 4ac, 36 minus 9 times 4 is also 36, which equals to 0. So when the discriminant equals to 0, then the problem has one solution. Okay, one solution. Now when you do the same thing to test out this problem, you're going to realize that the discriminant is going to be a negative number, and therefore the problem has no real solutions. Awesome. The last thing we want to do is we want to be able to write an equation from the solution. So this is the backward process, which instead of finding the usual solutions, this time you're given the solutions, and your job is to find the general function that would provide us with the given solution. So what we do is we go backward. If we know that these are the roots of a quadratic functions, if we know that these are the roots, so 5, and then maybe -4/3, and then the graph goes like this, and that's what we mean by the roots, then that means that they have to come off from a pair of binomials. If 5 is the solution, then what goes inside here would be x minus 5. And if -4/3 is the solution, then what goes in here would be x plus 4/3, and they have to equal to 0, right? And now what we do is we kind of distribute them. So we distribute the x times the x. That gives us an x squared. Distribute this. That gives you 4/3x. Distribute that. That gives you -5x. And then if you multiply that, that gives you -20/3. Find a common denominator by multiplying top and bottom of these by 3. That gives you -15. -15 plus 4, that gives you -11/3x. That's the middle term. So if these two are the solution, then this is what we call the general equation for your two roots. Okay. Find an equation. So here's an additional 2 roots. If that is the solution, then it has to come out of these 2 binomials. Okay. And then you multiply them together. And if you multiply them together, notice that you can actually use a special shortcut to multiply them. If you do so, you get x squared minus, in other words, the shortcut involves squaring the first term and squaring the second term. That becomes x squared minus 4 times 5. And that equals to x squared minus 20. This is the general equation that gives you those 2 solutions.